Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 5th, 2026, just about 4 days ago. It introduces a new benchmark called OdysseyArena that exposes a significant gap in current AI capabilities, finding that even top-tier models like Gemini 3 Pro Preview achieve only a 44% success rate when they have to figure out the rules of a task on their own. The paper is titled OdysseyArena, benchmarking large language models for long-horizon, active, and inductive interactions. And as we'll see later, the specific ways these agents get stuck are quite revealing for future model design. For those interested in the implementation, the authors have shared their code on GitHub. Well, Figure 1 captures exactly why this is so difficult. On the left, you see the standard deductive approach used in most benchmarks, where the agent is explicitly given the environment's rules, like a manual, so it simply needs to execute actions to reach a goal. But on the right, the inductive setting changes the game completely. Here, the agent faces an unknown world, represented by that question mark, and must actively observe and reason to discover the hidden rules for itself, building its own mental model from scratch. Table 1 places OdysseyArena in context with other major agent benchmarks like Gaia and WebArena. Notice the column labeled IND, short for inductive reasoning. Most recent benchmarks, marked with red crosses, completely skip this capability, focusing instead on following explicit instructions. The few that do support it, like Baby AI, often rely on simulators or shorter horizons. OdysseyArena, in the bottom row, stands out by demanding both inductive reasoning and an extra-long planning horizon of over 100 steps, which is necessary to see if an agent can truly learn from its own long-term experience. So, having seen where the benchmark fits, Figure 2 visualizes the 4 specific environments, each designed to test a different reasoning primitive. On the far left, the Turn On Lights task represents discrete symbolic rules, where the agent discovers hidden Boolean logic to activate all lights. Next, the AI trading panel introduces continuous stochastic dynamics, forcing the model to distinguish meaningful signals from market noise. The energy dispatch environment then tests periodic temporal patterns, such as managing cyclic energy supplies. Finally, on the right, the repo system simulates a coding environment, requiring relational reasoning to navigate complex software dependency graphs. Alright, to quantify the difficulty of that discovery process, Figure 4 details success rates in the Turn On Lights environment. The orange bars represent performance when rules are explicitly provided, while the blue hatched areas show the results when agents must infer them. Notice that frontier models like Grok 4, GPT-5, and Gemini 3 Pro Preview hit 100% success on the deductive task. But without the manual, performance crashes. Even Gemini 3 Pro Preview, the top performer, drops to about 44%, and GPT-5 falls to 28%. This gap highlights a severe bottleneck in inductive reasoning. Well, while the previous figure zoomed in on the lights task, Table 2 broadens the scope to all 4 environments. The top row establishes the human baseline, showing strong results, especially in the repo system where humans achieve a perfect 100% pass rate. Below that, Gemini 3 Pro Preview consistently leads the proprietary models. However, the energy dispatch column reveals a critical failure mode. Most open-source models flatline at 0 here, proving that even advanced agents struggle to identify the periodic patterns required for success. Wrapping up, OdysseyArena makes one thing clear. While current models excel at following explicit instructions, they struggle significantly when they must discover hidden rules on their own. This inductive bottleneck suggests that scaling alone may not yield true autonomous agency. Future progress will likely require architectures that can actively explore and build coherent world models from long-term experience. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.